equipment damage can go from manageable to catastrophic within fractions of seconds. Embedded AI offers the possibility to do intelligent signal processing within milliseconds, and that's one of the main advantages of having Edge AI. We have worked on an optimized framework that enables running real-time current signal classification on ultra-low power devices. And we have showcased with numbers that it is indeed feasible on an MCU that costs few dollars to have an inference in less than 5 milliseconds, consuming fractions of milliwatts. All of this while keeping levels of performance really high, so above 99%. It's about choosing the right intelligence, the right size, and knowing the right place to deploy it.
Welcome everyone. This is the AI at Scale podcast by Schneider Electric. My name is Ghaia Górska and I'm the host of this program. Today I have a pleasure welcoming Ghaia Belaakaria, Senior Data Scientist for Embedded AI at Schneider Electric. Welcome, Ghaia.
Thank you. It's a pleasure to be here.
Yeah, I'm so glad that you could join us. Could you tell us a bit more about your role at Schneider?
So, like you said, I'm a data scientist at the AI Hub of Schneider Electric, and I'm specialized in embedded AI. I am part of a team that holds the same name, the Embedded AI team. And simply put, what is embedded AI? It's when you run AI algorithms directly and locally on devices. So there is no need for a cloud or a remote server. And so it's intelligence running and living on the device itself. And concretely, the team's mission is to be the trusted partner of Schneider Electric's lines of businesses in terms of embedded AI, and that includes early stage investigations, proof of concepts, all the way up to industrialization.
Yes, exactly. And as you can imagine, the reason why I invited Ghaia is to dive into the world of embedded AI and understand why is it so difficult to keep AI models small. So could you tell us a bit more, Ghaia, how do you approach embedded AI and why it's such a challenge to keep them small?
So at the team and at Schneider Electric, we approach embedded AI through a frugality and efficiency perspective. Today, when we think of AI, the collective imagination would go straight to complex models that execute sophisticated tasks like ChatGPT. However, artificial intelligence is much more than that. It includes more tasks ranging from forecasting, classification, anomaly detection, and most of that can and sometimes should be able to run directly on the device. And today, embedded AI offers a strategic advantage in terms of efficiency. Actually, by design, this type of AI is frugal. And because processing data locally on the device is fundamentally less power hungry than sending everything to a remote server. And this is perfectly aligned with Schneider Electric's core missions, including energy efficiency and decarbonization.
So how is Edge AI improving the safety, reliability, and efficiency for our customers? Because we definitely observe a motivation to use more of the embedded AI, so it clearly solves some of the challenges of the customers. Could you tell us a bit more about it?
So the topic of safety and AI has always been a hot topic, and embedded AI has concrete answers to this point. In fact, by design and by nature, embedded AI offers a whole set of advantages, namely resilience and industrial reliability through autonomy, but also responsiveness and real-timeness through latency. And if we take speed, for example, you need to keep in mind that a cloud round trip in an industrial setting could take somewhere from 800 milliseconds to 2 seconds to provide a response. If you are monitoring vibration or current signal waveforms, that's physically impossible if you want intelligent processing happening real time at the spot, and equipment damage can go from manageable to catastrophic within fractions of seconds. Embedded AI offers the possibility to do intelligent signal processing within milliseconds, and that's one of the main advantages of having edge AI. If you add to that, so resilience, the question of resilience, say you have an industrial plant, and this plant is at a remote location. Inside the plant, you have electromagnetic interference, and you are not sure to have network available, so unstable network. And you would like to have monitoring systems everywhere near to your machines to regularly check the status of the machines. Well, if you count a lot on cloud for this purpose and you don't have connectivity, well, that's a single point of failure. On the other hand, if you incorporate functionalities that are based on edge AI happening locally near the machines, in that case, you guarantee that you are monitoring the plant even when the network fails. And overall, embedded AI offers a lot of efficiency in terms of cost, in terms of power consumption, because it's frugal, again. And today, one of the most expensive parts of AI at scale is data transmission. And since we are dealing with data locally, we do save bandwidth, we save power, and we save time by relying more in AI locally and edge AI.
Okay, and you mentioned some of the applications about monitoring certain processes, and I'm not surprised that customers are excited, but which are the applications of embedded AI that excites you the most?
So one recent concrete application of edge AI within Schneider Electric's products is the Space Logic touchscreen room controller. So it's based on a smart thermostat, and unlike static thermostats that follow static rules already predefined by the user, this one adapts and learns from the patterns of the occupancies of users within a building or a room. And it does so while guaranteeing the comfort of those users, but also saving energy. And one of the smart functionalities of this smart thermostat is that it's able to find the optimal start time based on a schedule of the user in order to soften the demand in terms of power and avoiding peak or simultaneous peaks of energy demand. And that's really smart and helps save energy up to 35% if we want to speak with numbers. And today, so this product is an award-winning product, and that tells a lot about the quality of engineering and the user experience.
And I was wondering, Raya, has this been always your area of interest? For how long have you been researching embedded AI? Because I know that you have graduated 2 years ago, and then you moved directly from academia to business. So how was this transition for you?
If I want to be honest with you, the transition was pretty smooth, and it's mainly thanks to the support, the welcome, and the confidence of my team. And also, I was first an intern when I joined the team, so it was a first step, and before jumping in as a full-time employee. But yeah. With that said, there is a gap to overcome between academia and business, between what we learn theoretically in school and when we are facing industrial constraints, when we deal with tangible business use cases of a real product under real operation conditions. It's a whole different scale, a whole different speed, and a whole entirely different set of priorities. So yes, it was really impressive. Both humbling and exciting as a fresh graduate, and I'm all here for it.
And as you mentioned that you did the internship, what was the biggest observation, the biggest difference for you between academia and the business setup for AI?
I would say it's definitely the approach to data. It's completely different. In school, when we work on AI and machine learning projects, most times we start with an already available dataset, pre-built dataset, specifically designed for an ease of use for such projects. And it's the type of datasets in research communities that are used for benchmark. And quickly, you move on to what I used to think the most challenging and complicated task, which is model development and experimenting with the architecture. In industry, the work starts way before that. It starts with building the data set, and it is what makes this whole experience richer and more complete. So in industry, we start with data, hardware-specific data, coming from the sensors of the products, coming from the product under the real-world scenarios where that product would be used. And then the effort required to go from raw data and to transform it into data valuable for AI and machine learning projects requires investment in time, in expertise, and that investment and that groundwork is what makes the difference. It's and the competitive advantage of such products and such projects.
I see. And in your current role, do you continue to research the topic? I know that you have been recently speaking at the conference about embedded AI. So, what is your occupation recently?
Yes, so like you said, yes, I definitely continue to do research, and the whole team does as well. And recently, not so long ago, I got the opportunity to present a paper, a research topic that was led within the team at the Embedded World Conference. It's one of the, if not the biggest, embedded electronic conference. And this work is actually very interesting. We have worked on an optimized framework that enables running real-time current signal classification on ultra-low power devices. And we have showcased with numbers that it is indeed feasible on an MCU that costs few dollars to have an inference in less than 5 milliseconds, consuming fractions of milliwatts. All of this while keeping levels of performance really high, so above 99%. And overall, I'm happy to be part of a team that is at the intersection of what is being done in the research. So we keep up with the latest cutting edge technologies, and at the same time, we apply it to real world products at Schneider Electric, and we try to extract value and find value from the latest technologies and bring it down to products and customers.
That sounds like an amazing innovation. Have you already submitted a patent for it?
Yes, definitely. Well, it's really necessary to protect such innovations. And what was interesting about this work is that it was not research for the sake of research. It was oriented to solve real problems, and we faced real constraints.
Yeah, that sounds amazing. And if we look a little bit into the future, what kind of directions you see for embedded AI in the next 3 to 5 years? Everyone now speaks about physical AI. Is it something that's going to be the next important thing in terms of AI applications in industrial context?
So the whole field of embedded AI is really dynamic, and it's going in multiple exciting directions. At one end, you have the positive obsession of wanting to be as small as possible and deploying methods and innovating into techniques that allow that. And today we know that in the ecosystem of embedded AI, industries and researchers are pushing to optimize either operators of AI and machine learning, either to make the hardware more compatible with neural networks, or between both to make tool chains and frameworks for deployment more optimized. On the other end of stuff, we can also speak today of physical AI. And it's where you have autonomous systems that don't simply perceive the world, the external world, but they do act in it. So robots that are intelligent, that are able to learn from the human behavior, to adapt to the environment, and to take real-time decisions. and all the computation is happening locally on the hardware, on the sensors of the robot, and on the actuators of the robot itself. So there are indeed multiple exciting directions in this field, and what ties everything together is what we have been discussing throughout. It's about choosing the right intelligence, the right size, and knowing the right place to deploy it. So where it operationally and environmentally makes sense. And Schneider's position is clear on that. It's about making AI more frugal. And yes, so I'm excited to be part of the ecosystem, and the whole team is part of the ecosystem. And we're looking forward to follow real time and firsthand what happens next.
Mm-hmm. And on this topic of making AI models smaller, so as you mentioned, it's not about the bigger the better. You have to be frugal. So, what do you think is missing right now in the technology to make models even smaller?
So the good news, I would say, is that the technology is already mature. We have demonstrations and even real products that show that today it's feasible. So that's very good news. And that's thanks to a very dynamic ecosystem that's pushing the research, that's pushing the innovations. I would say that now what's missing, and it's a limitation to all AI projects, is how to prepare data for such applications. But other than that, I think we have the necessary tools, and from what we have been able to achieve so far in the team, it's largely doable and feasible.
Mm-hmm. Yes, thank you for this. And my last question, Raya, would be maybe do you have any advice for people who are transitioning from academia to business? Maybe they are wondering if they should join Schneider. What would be your advice to them?
I think that if you're looking for dynamic teams, for strong collaborations, for a fruitful interaction, then yes, definitely you have your place at Schneider Electric. And my advice is to simply keep an open mind, to be able to balance between doing research but also apply it. Keep in mind that there is a goal and industrial objectives to meet, and the whole experience. It's something, an experience I recommend personally and that I enjoyed so far.
Thanks, Raya. That's really great advice for people transitioning or thinking about joining Schneider. I promise it will be the last question, but I have one more. I cannot keep it. And the question is, how do you keep up with the pace of the technology development in AI?
Well, in the team overall, we keep up by staying plugged in the ecosystem of embedded AI. It's a very rich ecosystem, and we are involved. The embedded AI team, on behalf of all of Schneider Electric, is involved in communities around Edge AI, namely the Edge AI Foundation. And I know that you had the opportunity to speak to Evgeny Gusev, who chairs the foundation, and being part of events and organizations around embedded AI guarantees us exposure, but from both sides, and interactions with and partnerships with the main stakeholders of the domain.
Mm-hmm. Yeah, thank you so much. So the cooperation is indeed very necessary in the field. Great. It was really nice talking to you, Raya. Thank you.
Thank you so much.
Thank you. And thank you to all listening and watching. Stay tuned for the next episode on your favorite podcast platform and YouTube. This episode marks the end of my role as the podcast host. I'm very grateful for the last 2 years spent together, 42 episodes. It was an amazing journey. I hand over to Tom Kroczak, who will be the next host of the AI at Scale podcast. Stay tuned for the next episodes. Thank you.